Okay, so polynomial functions of degree 1 is a really complicated way of saying straight lines. Here are four equations. We have 3x plus 2, which is this one, and 2x minus 4, which is that one, and minus 1/2 x is this here, and minus 1/2 x minus 4 is this one. Some of these graphs have things in common, and they ask, can you see what some of them are? They don't all have things in common, but there's a couple of things that we want you to notice as we remind you about these equations. First, these two lines, g of x and h of x, are parallel. And you can see that coming if you look at their equations because they both have the same multiplier on x. This number in front of the x is called the slope. And it tells you the direction that the line is in. A slope of 0 means the line is flat. A slope of like 1/10 or something means the line is climbing, but not very quickly. Something like, I don't know, 2/3 means the line's climbing a little faster. A slope of 1 means a 45-degree angle. Big slopes, if you have something like 10 or 20, means the line is climbing very quickly. And a vertical line, we either say it has no slope, or we'd say you could kind of get away with saying its slope is infinity. So the bigger the slope, the steeper the line. And if the line goes downhill, then it has a negative slope. So something like minus 1/10 or minus 2/3 means the same thing as far as steepness, but it means it's going down to the right instead of up to the right. So these two lines with identical slopes are parallel when you graph them. And the other thing we'd like you to notice is this number, not the slope, but the other number that's added or subtracted on the tail end, tells you where you're going to cross the y-axis. So this line is blah, 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 minus 4, and it crosses the y-axis at minus 4. This line is blah, 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 plus 0. There is nothing on the end, and it crosses the y-axis at 0. This line is blah, 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 minus 4, and it crosses the y-axis at minus 4. And this line is blah, 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 plus 2, and you'll never guess where it crosses. So when you're looking at a first-degree equation or a linear equation, the multiplier on x is the slope, tells you which way the line goes, and the number on the end, if any, tells you the y-intercept, which is where the line starts off on the y-axis. If you know those two things, you can sketch the line instantly. So that's what I see for common characteristics. Let's see if they bring up anything else. How does the constant term in the polynomial function relate to one of the characteristics? We covered that. The constant term is this number on the tail end, and it is the y-intercept of the function. If it looks like it doesn't have one, then the y-intercept is 0. How can you tell from the equation of the polynomial whether the line increases or decreases? As mentioned, that's the slope. If you have a positive slope, then your line goes uphill. If you have a negative slope, then your line goes downhill. The polynomial functions g of x and h of x are represented by parallel lines. How can we tell from the equations that this is the case? We saw that as well. Their slopes match. If two lines have the same slope, it means they're going in the same direction. They should end up parallel. So in general, what feature of the graph is represented by the leading coefficient? The slope, which is the direction the line goes in. So now, they're going to wrap all that up again by getting us to fill in some blanks. Generalize the above work to complete the following statements about all functions that look like y equals mx plus b. It'll generally be y equals, but f of x is okay as well. The shape of the graph is going to be a straight line, and it will have a slope of m. In other words, whatever multiplier is in front of x, that's your slope. The domain for lines is almost always x can be any member of the real numbers. We write that x is an element of the reals. So that symbol means belongs to or is an element of, and the symbol for the real numbers is an r with 2 downstrokes. And the range usually is y as an element of the real numbers. There are exceptions to both of these, but this is true 99% of the time. These lines have one x-intercept and one y-intercept normally, and the y-intercept, you can read right off the equation, it's b. It's this last number here, and it can be positive or negative. The direction of the line is determined from the value of the leading coefficient, in other words, by the slope. If the leading coefficient is positive, then your line slopes up. It'll go in this direction. And if your leading coefficient is negative, then the line slopes downhill like so. And finally, because the graph of this function is a straight line, we call it a linear function. So if you have y equals 6x minus 12, or anything that doesn't contain roots or x squared or x cubed or anything like that, it just contains x to the first power, we call that a linear function. We know that when we graph it, we're going to get some kind of straight line.